আচ্ছা, এটি মেগা 3 কোথায় আছে? এরকম তো থাকে অবশ্য, একটা টানা জয়েন। আর কি আছে? আর কি আছে? ঠিক আছে। আচ্ছা, দেখেন তো আজকে কয় তারিখ? আচ্ছা, তো আমরা লাস্ট ক্লাসে কি দেখছিলাম যে বেসিক পোর্ট পিনগুলো কীভাবে কাজ করে, আর হলো গিয়ে এটার ডিফারেন্ট ভিউ, মানে একটা মাইক্রো কন্ট্রোলিং ইউনিট আমি যখন বোর্ড একটা হাতে নেব, তো হাতে নিলে কি হবে, খুব ভালো হতো একটা আর্ডিনো থাকলে। আচ্ছা যাই হোক, এটা নেক্সট ক্লাসে দেখাবো। একটু মনে করে দিন তো গ্রুপের মধ্যে যে স্যার একটা আর্ডিনো নিয়ে আসেন। হ্যাঁ, তো এই যে বোর্ডটা থাকে, বোর্ডটা আলটিমেটলি কী হয় বলেন? এটা তো বিভিন্ন পিনস আছে, তাই না? আমরা পিন দিয়ে কানেক্ট করি ডিফারেন্ট টাইপের সেন্সরের সাথে, আউটপুটের সাথে। আচ্ছা, তার আগে আমি একটু বেসিক ব্লকটা নিয়ে যাই, ডাস্টার তো নাই। আচ্ছা, বেসিক ব্লকটা হলো গিয়ে দেখেন তো বুঝেন কি না। ফার্স্ট ক্লাসে একদম বুঝাইছিলাম যে আমরা এনভায়রনমেন্ট থেকে সেন্স করে ইনপুট নিই, তারপর একটা প্রসেসিং ইউনিট থাকে, ঠিক আছে, যেটা আমরা বলতেছি মাইক্রো কন্ট্রোলিং ইউনিট, তাই না? সে প্রসেস করে ওই অনুযায়ী কি আমরা একটা আউটপুট পাই। তো আউটপুটটাকে আমরা কী নাম দিচ্ছি বলুন তো? অ্যাকচুয়েটর। অ্যাকচুয়েটর মানে কি? অ্যাকচুয়েটর মানে হলো গিয়ে ইনপুটের বেসিসে একটা আরডিনো বোর্ড বা মাইক্রো কন্ট্রোল ইউনিট যে কাজটা করে, সেটা হলো কি অ্যাকচুয়েটরস, মানে বেসিক্যালি আউটপুট। এখন নর্মালি বাংলাদেশে অ্যাকচুয়েটর বলতে মোটর বোঝানো হয়। আমি যদি দোকানে গিয়ে বলি আমার একটা অ্যাকচুয়েটর দেন, তাহলে তখন আমি একটা লিনিয়ার মোটর দিবে। লিনিয়ার মোটর বুঝেন না? আচ্ছা, মোটর নর্মালি কী হয়, কয় প্রকার হয়? একটা 360 রোটেশন দেয়, তাই না? ক্লকওয়াইজ, অ্যান্টি ক্লকওয়াইজ, ছোটো বাচ্চার খেলনা গাড়িতে যেটা পাওয়া যায়। ওকে, তারপর কি হয় বলেন? আরেকটা কি আছে? 180 ডিগ্রি মোটর হয়, সার্ভো মোটর। বুঝাতে পারছি? 180 ডিগ্রি, একবার এইখানে আছে, এখান থেকে এই আসবে আর সামনে যাবে না, বুঝতে পারছেন? আবার ব্যাক করবে, তো ওর রেঞ্জ হলো গিয়ে 180 ডিগ্রি। এটাকে অবশ্য বাড়ানো কমানো যায়। তো সার্ভো মোটরের স্পেশালিটি হলো গিয়ে আলটিমেটলি আপনি ওকে পার্টিকুলার টর্ক অনুযায়ী, মানে এটা দিয়ে আপনি গাড়ি ঘুরাতে পারবেন না, সার্ভো দিয়ে কেউ গাড়ি চালায় না, ঠিক আছে? লোড ক্যারি করা, মুভ করার জন্য, সাপোজ আমি এখানে আসি, একটা ভারী বস্তুকে নিয়ে এখান থেকে এখানে রাখলাম, তো সেক্ষেত্রে তো আমার স্পিড দিয়ে কোনো কাজ নাই, আমি তো ওটা নিয়ে তো আমি ঘুরে কারো মাথায় কিক মারবো না, তাই না? তো আমার কী করতে হবে, ওইটা নিয়ে এখান থেকে মুভ করে এখানে রাখতে হবে। তো ওইখানে আমার টর্কটা বেশি দরকার, মানে শক্তিরও বেশি দরকার, ঠিক আছে? আচ্ছা ভাই, তো এর ক্লাসগুলো আমি ইংলিশে নিয়েছি, তো আমার ইংলিশে কথা বলে সমস্যা আছে ওদের? বদরুল, ইংলিশে ক্লাস নিলে সমস্যা আছে? মানে এর আগেগুলো ইংলিশে নিছি, ওই যে ও ক্লাস করছে তো, মানে বাংলাতে করি নাই। যদি সমস্যা হয় হাত তুলে বললো যে এটা বুঝি নাই, বুঝাই দেব, ঠিক আছে? আচ্ছা, okay, so in our first class we have come to know about sensors, okay, then we have come to know about microcontrolling unit, and then after processing that signal we have come to know that we will get some significant output according to the input. So how do we get the value of the inputs? How? Have any idea? I have put an example, like in this room, if I am feeling hot or feeling cold, it's something that my glands are taking some values of temperature from the environment, isn't it? So is there any kind of example you want to put it down right now, like that can sense actually? One example I can say, what actually do the fire sensing alarms? if there is a fire extinction right there, okay, the fire will burst out and it will spread towards the room, and that sensor will sense the heat or the temperature of the fire and started to throw the carbon monoxide or carbon dioxide. Okay, do you get my point? So how do you come to know that there will be some multiple inputs in this area? Can you say some example about inputs? Like I have give an example of the water level. So the water will hit the particular indicator, and that will be the input. The heat will be the input. The temperature will be the input ultimately. Okay. Pressure will be the input. So can you say any example of inputs that can be controlled by the microcontroller unit, and the output will come from that particular input? Any example, please? Sabir, any example? So what will be the input of the system? Obstacle. Obstacle can't be an input. The distance will be the ultimate input. Do you get my point? Suppose I am standing right here, the sensor will sense that there is some object over there. So there is two different sense. One is there is an object, and other is the how much distance it will cover to reach the object near me, or how much does it take long to get down or over there from the particular place. So the distance will be the input. Okay, the distance will be the input, the presence will be the input. Suppose there is no person in that room, and the lights will off automatically. How is this possible? So it will count the presence. Okay, then it comes to PIR sensor. So there is a basic difference PIR and sonar sensor. You have given example of a sonar sensor that count the distance ultimately. That's not the presence of the obstacle. Okay, if you want to get the obstacle, if you want to get the presence of any object, it will come from a PIR sensor. Like there is no one in the room, the lights are off. If you just entering in the room, the lights will on. How do you get to know that lights will get on? Okay, so the PIR sensor will detect the motion of yours, the presence of yours. Okay, and when we'll get the presence of yours, it will get some value or execute some value like 10. This value we're going to produce from this Arduino part, and that when he or it will produce the value of 10, then it will tell the actuator. So what will be the actuator? LED, motor, then servo, whatever it has. Okay, so ultimately the LED will turn on. So are you getting my point? When there will be a presence of a person in the particular room, the MCU will sense, basically the sensor will sense the presence of the room, the person. Then the MCU will calculate the value or process the ultimate result. Okay, he is delivering something and I have to generate a value, and the value is, let's say, 10. Okay, so it's all about numbers, 0, 1, 2, 3, 4, 10, 12, 100. So, and you can say easily 1 or 0. Okay, it will get easier. So it will get 1. The Arduino will get the value of 1. So when you will get the value of 1, it means you have to turn on the light. Okay, so there will be a question that how this Arduino is going to turn on that light. Okay, so this Arduino will turn on the light by increasing the value of pin number. Okay, sorry, increase the value of the pin, or it will just make higher to the pin number. Like every pin is now set to the 0. Okay, digital pin, I say digital pin is setting to the 0, let's say. So it means what? 0 means off and 1 means on. So when this 0 will come to 1, that means on. And if you put a wire with the particular LED, is the LED turn on or turn off? Turn on. It seems that this one is ultimately is regulating the circuit. Okay, is pushing the electron to the circuit. let's say very easy example. Here is a battery source, 5 volt. Okay, there is a resistance and there is a LED. So, are you familiar to this circuit? It's a very basic circuit. So 5 volt plus minus, it will throw the current from here and the LED will turn on, and after that when the voltage source will be off, or if I just put a switch over there and the switch is off, switch is off, then this LED will off. If the switch is on, then the LED will on. It means it depends upon 1 and 0, is it? So this switching is going to happen with this 1 and 0. Okay, so ultimately it is getting some voltage, and after getting the voltage it will power up by itself, and when we get value from this sensor, it will regulate the value of 0 and 1, and if it comes to 1, if it's getting something value like 1, then it will generate its value personally 1, and this 1 will turn on the ultimate LED because you are connected the LED with this light. Okay, so now the question is how we are going to put the ultimate voltage to this particular board, isn't it? So it's not like it's an open circuit, it must need to be a closed circuit. So to turn on this LED 1 and 0 or the ultimate value, it needs some power. So this power will come from different sources. So now I will let you know about the particular specific. So did you get the ultimate theme of this board? Okay. Now you'll get to know about how this MCU or Arduino board is going to powered. Okay. So there are two portions. This is the communication port, COM port, or sketching upload port. Okay. So what's the benefits of this port? When you have a laptop and you have an Arduino, so with the particular USB type B, type C, whatever you have to the laptop, and it has the type, what is the type A or B, whatever, there is some round shape something, and you have to connect this Arduino. It's something like you are connecting the mobile with the laptop. Okay, so you have to connect this Arduino with this laptop. So when you are connecting this Arduino with the laptop, this Arduino will get power automatically like the range of 5 volt. So when you are connecting the laptop with the phone, it will get also power with a particular and nominal voltage. So it has been said previously that whenever you are connecting any consuming device, this is obviously a current consuming device. This device is not going to power the laptop. Laptop is going to be, this is going to be powered by the laptop. Okay. So when you are connecting the port, ultimately coding port, the USB port or the printer cable, this is going to be powered and it can generate the ultimate value that is going to be find from the sensors. Okay, there is another way, is a black portion. So it's also a power jack. Okay. So if you have any 3 mm port and you have an adapter, so with the help of the AC circuit, like you are going to connect with the AC voltage, so you have an adapter, so you touch the adapter with the ultimate board, and then you have a wire and you have an Arduino board, so you have to connect that port to this particular black portion area. Okay, so this is the power jack with the 3 mm cable. Okay, so now the question is, you have a compact package, you have a compact project. Okay, is it possible to connect that AC current to that particular? Is it possible, Bodru? It's impossible. It's possible if you are stacking or you are setting in a particular place, like you are setting a board towards the CC camera, towards over the AC, or right over the board or something, you have to fix it. Then you have a connection, then you can connect with the particular AC current. But if you want to move a project like obstacle avoiding robot, you can't put AC current over there, and you can never connect that AC current to that particular robot. It's quite impossible because you have to move the robot, and there will be always connected wire that you have to stretching day by day to the particular distance. So it's quite impossible. So you have to find the particular project that you are going to launch, and for that particular project you have to know that whether I am connecting with this port or this port. Okay, so as I'm talking about power section of the specification, so how many specifications we have find out so far? Number 1, specifications. Okay, so today is the main topic of our class is about the specification of this Arduino board. So number 1, what? This port actually operating or generating 5 voltage. Okay, right now number 1, operating voltage. Okay, so basically an Arduino need an 5 volt voltage, and you may support it from here and from here also. Operating voltage 5 volt. Okay, number 2, so with the help of the adapter you are providing 5 volt over there. With the help of the port you are providing 5 volt over there, so it will be powered up. Another question is, if I connecting the 5 volt from both sides, that won't be a problem. It's not going to burst out, because I repeat, a current consuming device is his or her choice whether I'm taking the current or not. Okay, you can put the voltage to the particular current consuming device. It's a current consuming device. This phone is a current consuming device. This laptop is a current consuming device, because if at the end of the day it will get lower in charge. Okay, it's not to the same phase at all the time. So ultimately it needs some current. So the device which needs current is the current consuming device. So the current consuming device just follow the basic protocols, the basic phenomenon of what? Of current. Okay, that if you just say like I'm going to push it to that particular device 100 ampere, it's okay, no problem. This is not human being that I'm pushing the current 100 ampere and I'm going to die at that moment. That's not going to work like this. So this device is going to work like, if you are going to give him 100 ampere, it will take by its choice. If it needs 3 ampere, like it has a thirst of 3 ampere, so you can give it to that particular ampere, but it will take to that, then don't take too much over there. Okay, like 97 ampere will be released to the ultimate source, and it will go to waste, or it will just remain as simple as in the source. Okay, he has no any interest to that particular 97 ampere. It's simple. It's very much simple. If you are thirst of 1 glass of water, I may give you 2 glasses of water, and at best you can take 1.5 glass of water, because you don't have any thirst. And if you are just fully stuck and you can move around there after drinking a half or 1.5 glass of water, then you have no choice to take the extra half glass of water or the 1 glass of water more. So it's all about your thirst, isn't it? So the thirst is basically the thirst of the device is the 3 ampere, is a 3 glass of water. Okay, if you compare to the particular relevant voltage or relevant current. So ultimately it has a thirst of very nominal current, very specific current. It's just less than 1 ampere. Okay, so if you are going to connect this Arduino board to the particular adapter, to the particular source of 5 volt 3 ampere, it doesn't bother. Okay, it needs just 50 milliampere or 0.5 ampere. It will take 0.5 ampere throughout the voltage source, and ultimately it will run his operation or its operation as smooth as it can. Okay, you can put 9 volt, 10 volt. I'm just going to jump to the other sections. Just wait for the. I'm going to come to your answers. Before that, so it depends upon your current, and this is a very good question. If I'm going to put the 9 volt, 8 volt, what will happen? So it doesn't bother. But the voltage is the pushing of electrons. Okay, so if there is no voltage, there will be no current. So it's ultimately relevant and vice versa. Therefore, I can say that 9 volt, 10 volt, 8 volt, you can give him to him. But how? There is one port which is stuck with the 5 volt. There is one port which is connected with the laptop or PC or any adapter, whatever you have, or power bank. Okay, you can also power with the power bank. Now, I am not going to use any power bank. I am not going to use any laptop because I have to make it compact. So the one thing I can use is what? For the power supply. Exactly, battery. So it can be lead acid battery, lithium-ion battery. Okay, any battery can be selected for the particular task. Okay, so it has a input voltage recommended. Okay, it's 7 to 12 volt of specification. Okay, so the output voltage is 5 volt, input voltage (7 to 12 volt). Okay, it's recommended voltage. Okay, and there is a limit of input voltage. At maximum it can take from the source actually 6 to 20 volt. So it's not safe to give 18 volt, 17 volt, 20 volt. It's better to keep the range in 7 to 12 volt. So if you have a lithium-ion battery of 12 volt and you are connecting with the Arduino, this Arduino will never going to burst down. But if we are putting a voltage 20 volt, 21 volt, 18 volt, there is a very much high chances to burst out of this Arduino board, because he or it will take the particular ampere or the current consuming sense or the ultimate current from the voltage source, but it can never defend the ultimately voltage. Okay, it can defend the current, that I need that particular current and my thirst is now, I have just fill up my thirst. Okay, I just don't need any extra ampere. So he or she can protest that ultimate ampere, but he can never protest the voltage, because voltage is the particular source where it is the king of the all over the things. Now how it works, if you have a motor, Bodrul, if you have a motor of 5 volt and you are giving the 5 volt to that motor, what will happen? The motor will run slowly, the motor will run very fast, or the motor will run as its demand or in a normal way? In a normal way. Okay. So Bodrul, if I am going to provide 2.5 volt to a 5 volt motor, then what will happen? If it runs slowly, or it will move slowly or move faster? If you have a motor of 5 volt and you are providing a voltage source of 2.5 volt, so it will run slowly, okay, it will move slowly. And if you have a motor of 5 volt and you are providing 10 volt to that motor, what will happen? It will going to operate or moves very much faster than the previous stage, right? So then the question comes to your mind, if I'm going to put 12, 15 volt, it will move very faster. So the electromagnetic coil will going to produce more torque and speed, right? What will happen if I am going to set 20 volt to that 5 volt motor? Okay, so it will start it very faster, and after that, after some time, you will see that this is going to be feel the warmth or heat of the motor, right? And after 2 or 3 seconds, it will just dead. Okay, why it happens? Because it's not about the current. It has no control about the voltage source. Because when he is getting the voltage, ultimate voltage, then it will operate its own way by taking the current. But the voltage is pushing the extra current to make more faster, more operational work. Okay, so the voltage will make him more faster, but with the minimum range. It is not the moving device. Okay, it's a static device that will set to any particular place. It's not going to like it will fly, it will move. Okay, it will roaming around you. It's not like this. It's a static device, so it has a nominal voltage of 5 volt. That's okay. And if you're putting 7 volt, 10 volt, 12 volt, then it's okay. But after some time, if you cross its limitation, then it will just burst out. So to prevent the circuit for safety, there is a voltage regulator over there, you can see. Okay, so there is a voltage regulator over there to protect the device. You are using fuse to ultimately support your, to save your laptops, phones, if there is any cyber attack, if there is any thunder over there to your house, okay. Is there any fault, ground fault or any kind of fault in your AC current or home management current system, then you have a fuse. So it has also a fuse and a regulator to save its own way. So that's the specification. There is more specification, like there are some digital pins. I have explained about the digital pins of it. In the next class, I will definitely take the Arduino and you will let you know about the digital pins of it. So digital pins, how many digital pins it has? 14. So it's called IO pin, input output pin. Okay, please write down the specification to your copy. These specifications are very much important to operate the Arduino board. And gradually we will jump to the pin diagram, the codes, because the codes is very much important for the particular executions. Okay, there are obviously PWM pin, pulse width modulation, PWM pin, 6 PWM pins. Okay, these PWM pins are specific pins because if you don't have any PWM pins, you can't operate the motor, open rotating device. Do you get my point? If you don't have any PWM pin, you can't operate the motors. Okay, let's say you have a LED light. So the intensity is not much important, whether it's dim or it's very brighter or less bright. The importance is whether it is on or off. So for the on and off, you need two values. What is 0 and 1? Okay, but for a particular motor, for a particular rotating device, do you need any on and off? You are driving a car and you are just pressing the accelerator, it will just go faster than your imagination or expectation, and if you just stop, then it will stop. You are not going to operate a car, or you are not going to be a driver like this. Okay, so you have a control over the motor. Sometimes you need to be slower, sometimes you need to be very faster, sometimes you need to stop the car. So you need a very long range of value. Okay, and that value considered to 0 to what? 255. Okay, so these analog pins, these analog value considered obviously to the analog pins, but the PWM pins are the special pins to control the motors, because you have to connect the driver, you have to connect the motors. So PWM pin is a special pin that is not going to be operated with the digital pins. Okay, we'll discuss this later in the further class, but to let you know the gist of the PWM pin, I'm just saying about that. Number 4, digital pins 14 IO, input output pins. These all are input and output pins. Okay, Bodru, what is input pins and what is output pins? Input pins are connected with what? Sensor or actuators? Exactly. And the output pins? Actuator. Okay. So if you turn on the LED, so you have to connect with the output pins. If you turn on the, if you are going to connect with the sensor, then you have to connect with the input pins. Basically, the one pin can be considered as the input, and that one pin can be considered as your output. Okay. So where is the particular execution of the coding or the sketch? You get my point? Where is the particular execution of the coding over there? I mean, what is the benefits or what is the need of the coding over there? Do you get my point? How these codings comes to this Arduino? I mean, where we are going to utilize the coding over there? Exactly, input output. Very good answer. Because the whole is same. Okay, the connection is same, but with your instruction, that hole, that connection can be worked as an input, and with your instruction, that particular hole and that connection, that circuit can be worked as output. Okay, so to this instruction in the language of engineering on respective board is called coding. Okay, because he or it will get some instruction. It's not like your language. Okay, do like this. Hey, tu eta kor. Okay, you have to put some particular grammar, put some particular language that is understandable to him. That's why you have to know the codes. Okay, so that's the importance of coding. Why you should know the codes and how we are going to operate with the particular actuators and how we're going to taking value from sensors. Okay, it's not like you are connecting that and every time it will work on its own way. So you have to put some instruction over there. Okay, so it has, so if every pin, what it has, every pin has a limiting voltage of 3 to 5 volt. It's like to turn on the LED, to turn on the motor or something, and that pin has a specific current. It's very less current. It's 6 milliampere. Okay, so the DC input output pins consider 6 milliampere every pin. Okay, sorry, 20 milliampere. It's not 6. Sorry, 20 milliampere. My mistake. 20 milliampere. Okay, that's a IO pin. And yes, okay. So there are some basic difference between the microprocessor and microcontroller. Do you know about that? No, it's not same. Okay.
Microcontroller is a complete like computer.
It's not like computer, complete package with RAM, ROM, with memory. So what is the significant difference? Microprocessor is costly. It is very much in cheap. Microprocessor has a very strong RAM, ROM, whereas it has less RAM, ROM and memory in microcontroller unit. Okay, you cannot operate a game, you cannot operate the whole PC with the microcontroller, but you can operate the all stuffs, browsing, internet, gaming, Word file with your microprocessor. So it has a very range of power in what? In power consumption, in RAM, in read write, I mean RAM, ROM, okay, in memories. Okay, so there is a difference of memories over there. So it has 3 kind of memories. Flash memory, okay, I'm just rubbing it, erasing it from the board. How many memories it have? Flash memory, then what is that? SRAM and EEPROM. SRAM, static RAM, and EPROM. Is it okay? EEPROM, yes. 2 kilobyte, 1 kilobyte. So you have already know that we have already known about that this 1 kilobyte is the most smallest size that ever can be, isn't it? Your basic file size of Word file is 1 MB or 420 kilobyte. Okay, it's just 1 kilobyte. So you can put a Word file over there. So your task and operation are limited. Okay, the thing you can operate with the computer is not going to happen or it's going to be executed with that particular Arduino board. Do you get my point? It's a very small memory, EPROM. EPROM is a safe memory. You can save a particular code over there. So you can save it, but you can save more than that. Flash memory, it has a flash memory of 32 kilobyte and it is a SRAM of 2 kilobyte. So, yes. Okay. So it's not going to, execute the as same as the microprocessor. Okay. So we'll talk about the power and the more specification on the next class. Please remind me about that and have a text on the group to take Arduino with me. That please take a reminder over that I will come down with the Arduino over the next class. Okay. Thank you. Assalamu alaikum.